நம்மளுக்கும் அடுத்தடுத்து வேலை இருக்கு. நம்ம மட்டும் எல்லாருமே இதை பத்தி யோசிக்கல. இல்ல நான் வேலைக்கு வரேன். நம்ம வேலையை நம்ம ஒரு ஈடுபாடு செஞ்சுக்கிட்டுதான் இருக்கோம். இல்லைனாலும் இந்த 1.5 மாசமும் செஞ்சுக்கிட்டுதான் இருக்கோம். எப்ப கஷ்டத்துலயும் வந்து எல்லாம் செஞ்சுக்கிட்டுதான் இருக்கோம். பயமுறுத்துற மாதிரி நம்மளோட இதுல
শোনা যাচ্ছে না? শোনা যাচ্ছে এবার? ক্যামেরা এসে গেছে না? ক্যামেরাটা এসে গেছে, শুনতে পাচ্ছ না এখন? পরিষ্কার শুনতে পাচ্ছ? আচ্ছা, আমি আমার এখানে মাইকটা আমি অন করিনি, ওটার সাথে আমার মাউসটা আছে, সুতরাং আমি শুনতে পাচ্ছ না আমাকে ক্লিয়ারলি?
হ্যাঁ, শোনা যাচ্ছে স্যার।
কটার সময় শুরু হবে? আচ্ছা, আমি থাকবো তাহলে, আমি এখন এখানে আছি। হ্যাঁ, ওকে, আমি এখানে আছি তাহলে, ঠিক আছে। শরীদ শুনতে পাচ্ছ? শোনা যাচ্ছে? হ্যালো, সবাইকে ক্যামেরা অফ করতে বলো। শরীর, ভিডিও অন করো। সবাইকে অডিও মিউট করতে বলে দিও সবাইকে, অডিও মিউট করতে। হরিমোহন, অডিও অন করো। হরিমোহন, অডিও অন করো। অডিও, হ্যালো, Hariman is there?
Yes, I am very much here.
So can you see me? I am waving my hand.
Okay.
Hello?
Fine.
Yes.
Nice. Nice to see you.
बहुत दिन के बाद मुलाकात हो रही है.
Right.
बहुत दिन के बाद.
Oh, yes. बहुत दिन बाद. That's
Yes,
correct.
yes.
Yeah.
Definitely.
Okay.
Very nice that you are here.
Yes.
बाद में फोन में बात करूंगा. हरिमान.
हाँ. Sure.
बाद में फोन से बात करूंगा.
Yes. बिल्कुल.
लेकिन रहना अभी थोड़ी देर मेरे साथ थोड़ी देर रहना. Am I audible?
Yes, you are audible to me.
Yes, sir.
Yeah. Thank you.
May I request all participants present here, please mute your microphone and switch on your videos, please. Geeta Murugan, ma'am, please mute your microphone.
Hello, Professor Ray. Professor Ray. Professor KP Ray. Hello.
Good
Professor
morning,
Ray.
sir. How are you?
I'm doing well.
Yes. Nice to meet you here, sir.
Yes, thank you very much. Nice to see you too.
Yeah. Good morning, Dr. Pal, Professor Pal.
Yes, Sarit Pal.
Yes, Professor Gupta, I can see.
Yes, Professor Gupta is here. Hariman.
Yeah. Very much here.
My friend.
Yes. Yeah. We have met earlier.
Yes. We are together at IIT Kharagpur. Hariman and myself.
Right.
Yeah,
Right.
we are students there.
Okay. I was traveling, so I was not able to correspond with everyone in time. So
Yes. We'll listen to your ultraband antenna lecture.
yeah, first your lecture is there, sir. So that will be very enlightening.
Yes, ultraband antenna lecture. Yes.
Should we start, sir?
26. What is the time now? What is the time? 11:17.
11:17.
Have a word with Sarit Pal, Professor Sarit Pal. Have a word with him and then start. Is he there? Is he around?
Shoritpal, sir, you are not audible. We can't hear you.
Call him on phone.
Show him a paper.
Just call him on phone.
I think he might have muted his phone.
No, through phone you contact him, through telephone. Contact him.
Hello, sir.
Yeah. Deepta wants to know
Can you hear me, sir?
whether we should start. She wants to know. Can you hear, Professor Pal?
Yes, sir. Can you hear me, sir?
Or wait for some time? Should we start?
You can start, sir. Deepta, can you hear me? Can you hear me? Hello? Hello, Deepta, can you hear us? Hello?
Yeah, we are able to hear him, but sound is not very clear.
Hello, Deepta?
Sarit, yes, Sarit. We cannot hear him. Sarit, you cannot be heard. No, you are not audible. Sarit, you are not audible.
Some sound problem.
Sir, they are arranging another setup. Few minutes.
Mr. Raj Singh is there? Hello? Mr. Raj Singh? Mr. Raj Singh?
Hello?
Yeah, I think Raj Singh was there a moment earlier.
Yeah. He was there. Okay.
Hello? Hello? Deepta, is he audible? Hello?
Hello? Okay, okay.
Should we start, sir?
Now, Aditya can start.
May I start, sir?
Yeah. Start.
Am I audible?
Yeah, you are audible.
Hello.
Very clearly audible. Am I speaking to Deepta?
Yeah.
Please go ahead.
Yes, sir.
Deepta,
Please go ahead. Yeah.
Okay.
she is hosting the program.
A very good morning to everyone. On behalf of Electronics and Communication Engineering Department of Dr. B.C. Roy Engineering College, Durgapur, I wholeheartedly welcome our guest of honor, Professor Dr. Boidyanath Basu sir, Honorable Dr. B.C. Roy Engineering College, Durgapur, Professor Dr. Sanjay S. Pawar, Vice Principal, Professor Dr. K.M. Hussain, HOD of Electronics and Communication Engineering Department, Professor Dr. Narendranath Pathak, and all other dignitaries and respected faculty members present here. Electronics and Communication Engineering Department of Dr. B.C. Roy Engineering College, Durgapur has organized a 5 days faculty development program on recent trends and advances in electronics. Technology development creates many challenges in the education of industrial electronics related subjects. At the same time, it allows new educational models to be implemented. This faculty development program initiates a discussion for the needs and challenges of recent trends in electronics, which will meet the requirements of the emerging technologies of this century. Due to some unavoidable circumstances, our Honorable Principal Sir cannot be present in the inaugural ceremony, but he had sent his valuable messages. Sir, is it visible?
Yeah.
Okay.
ব্যানারগুলো একটু করে
Hey,
দিস।
this side is not audible. Hello. This side is not audible.
Sir, I am not audible.
Yeah, you are audible, but speech of principal is not audible.
The video message is not audible.
Okay, sir.
Sections. I'm very happy to invite you all, and it's a very challenging situation nowadays for experts from electronics and communication. There has been new areas of the work that expanded because of the requirements from the various domain point of view. Either it might be a networking, it might be an extended version of application assistance from the frequency point of view. It might be from electronics and communication, real studies and point of view. Various challenges are there. And based upon this and whatever the future areas are there, I think this FDP will make you have an interest into these areas, whichever may be the field you're working into. The challenges I'm saying because in case of an electronics, it's a vast area, and maintaining the old version might not be sufficient, but we should look into the new research areas that are coming in the picture. And in addition with this picture, in addition with this new areas, what is also important is how do I interconnect these activities. For example, let's say I'm working in 5G and 6G, and similarly, the real citizen areas are there, nano electronics areas are there, IoT is there, networking is there. So there are a combination of those areas, which is very important for all of us to understand the basic concepts and identify the research areas in this area. I have gone through the profile of the various speakers that are being part of this faculty development program, and they are the one of the most senior persons in the country, and they are, I can say, they have been a boss in from the technology point of view in their own area. And it would be literally a feast for all of us to listen to these people and gain insight into each and every area and to expand our research activities. It has been challenging for an electronics and engineering people, but if you have a positive attitude, if you have interest in taking up the challenges of the latest things that are being expected, I'm sure the sky is the limit for your progress and the success. And one of the reasons for hosting this faculty development program is to create an interest into these activities, which some of the areas might be bit forbidden to the general public because of the unavailability of an expert people. So these are the expert people, and I'm sure whatever your basic programs, basic ideas, or basic queries, or in creating it, this would be resolved in the faculty development program. Again, I'm repeating many times again, the faculty development program should not be only to assign a weak program and forget all the things, but it is very important for the stock and participant to get in touch with the research.
Okay. Dita, it's not audible actually, it's stopped. Dita net high virus. Very है सर.
Thank you, sir. There was a connection problem. May I request our Honorable Vice Principal, sir, to say a few words?
Good morning. Good morning, the organizers, uh, the honorable speakers of the 5 days FDP program, and the participants. At the very outset, I would like to congratulate and thanks to the organizer of this particular FDP, in particular Professor Sonit Pal, Professor Tapas Mandal. I would also like to thanks to the head of the department, Professor Narendranath Pathak, who has encouraged their faculty members to initiate this sort of the FDP for their departmental teachers and for also the faculties who are there across the country. I would like to also thank all the erudite speakers who had agreed to be the part of this 5 days FDP program. It's really a matter of pride and glamour, glory for us that we have got you in this platform of the 5 days FDP program. We are really, really grateful for you. On behalf of the BCRI Inter Fraternity, we'd like to extend our heartfelt gratitude to all of you, all the adept who are the adept in their subjects, all these erudite personalities. We like to extend our gratitude to all of you, sir. We are fortunate that we have got you in this particular FDP, but at the same time, we are also unfortunate that we have not received you in the physical mode. But whenever the opportunity comes, sir, in the latter days, I hope that we will get you in the physical mode. On behalf of the BCRC fraternity, I would like to extend our invitation to all these honorable speakers. If you get any opportunity to come down to our campus, please do come here. We'll make every arrangement for you, and we assure you every sort of hospitality to you. There are the three stakeholders for this particular FDP. One is the organizer, that is our AC department of Dr. B. Sri College, then the erudite speakers and the participants, who are basically the target of this particular FDP. So I would like to say to all the participants, first of all, I'd like to extend the thanks to all of you for joining this particular FDP. But at the same time, we need to understand why we need to attain this FDP. So basically, the FDPs are not to gain the certificate at the end of this 5 days program, but at the end of this 5 day program, we should get enriched by the lessons, by the learnings that we will like to get from this 14 erudite personalities, 14 towering intellectuals who are there, who have agreed to join from the different institutes across the country. So enriching ourselves, and it will in turn will help our students to enrich. So the basic target, though the basic target is not the faculties, but the basic target here is the students. So the intention for arranging this type of the FDP is for our students. That is the thing that you need to keep in mind whenever we are organizing this sort of the FDP or we are participating in this sort of the FDP. So I hope that you will all enjoy this 5 days FDP program, and I am sure that with the contribution of these erudite personalities, you can gain a lot from this particular FDP as far as the electronics and communication is concerned. Now, we at the BCRI Engineering College, here we are in Durgapur for the last 22 years. We have started our journey in 2000, and we are now a 22 years youth, having lots of energy. We are risky. We have lots of energy. We have lots of desire. We have lots of dream, and we are following that. We are following to get all those achievements in the near future. We have a campus of nearly 14 acres. We have started our journey with 4 undergraduate disciplines, that is the electrical, electronics and communication, IT and computer science. But now we are adorned with the 9 undergraduate disciplines, and with that we have the 4 postgraduate disciplines in engineering, and also there are the 2 major postgraduate courses are there. One is the MCA and MBA. So BCRI Engineering College is a huge college with lots of facilities, lots of departments. We have nearly 180 faculties, of which nearly 50% are they are with PhD. So we are very happy to extend our invitation to all the participants here. We welcome you all to this 5 days FDP program. Now, as far as the topics for the FDP is concerned, is the recent trends and advances in electronics. As you know, the entire world is now under the reign of these electronics and the communication. Whatever you see across here, we cannot imagine a single device which is not without electronics. So we need to, being the professors, being the teachers, being the spearhead for the society, for our students, we need to know what are the recent trends that is going on as far as the electronics and communication engineering is concerned. Some of the things that I have gone through is that in the semiconductor industry, the silicon has played the major role. The material silicon played the major role. We are very much reliant on the silicon. But as the days going on, we find that there are some limitations as far as silicon is concerned, as far as the etching lithography is concerned. But in this regard, lots of work is going on the advanced materials. As for example, lots of works are going on in the gallium nitride, which is another material on which this sort of limitations can be overcome. Similarly, we can also use the organic electronics. Presently, what we are using is the inorganic electronics, but the days that are coming where we are going to use the organic electronics. Now, whenever we use the organic electronics, that may help us to in the field. That may help us as far as the cost efficiency is concerned, as far as the socio-economic point is concerned, as far as they are biodegradable and they are also environment friendly. So lots of opportunities are there. Lots of research is going on as far as the electronics is concerned. And so I think that in the next 5 days, we will enjoy a lot. We will gain lots of learning from our erudite speakers who have agreed to join with us. And with this, I would like to extend my best wishes to all the participants, all the speakers, and the organizers for conducting these 5 days FDP. Thank you. Thank you very much, sir.
Thank you, sir, for your valuable informative thoughts. Now we will move towards our session. In today's session, first speaker is Professor Dr. Boidyanath Basu, sir. Professor Boidyanath Basu received BTech, MTech, and PhD degrees from the Institute of Radiophysics and Electronics, Calcutta University in 1956, 1966, and 1976, respectively. He was superannuated as professor and head of Electronics Engineering Department and coordinator of Center of Research in Microwave Tubes at Institute of Technology, Banaras Hindu University, which is now known as IIT BHU, India. Presently, he is adjunct professor at Sir J.C. Bose School of Engineering, Supreme Knowledge Foundation Group of Institutions, Mankundu, West Bengal, India. Earlier, besides IIT BHU and SKFGI Mankundu, he served several other organizations in India. National Institute of Technology, Jamshedpur, CSIR, that is Central Electronics Engineering Research Institute, CEERI, Pilani, DRDO, that is Defense Electronics Research Laboratory, Hyderabad, and College of Engineering and Technology, IFTM, Moradabad. Professor Basu has authored more than 125 research papers in journals of international repute and 7 monograph chapters in the area of vacuum electronic devices. He has authored 4 books: Electromagnetic Theory and Applications in Beam Wave Electronics, Technical Writing, Engineering Electromagnetics Essential, High Power Microwave Tubes, Basics and Trends. He is recipient of IETE Lifetime Achievement Award, Lifetime Achievement Award, Vacuum Electronic Devices and Application Society, India, SVC IA Memorial Award of IETE India, and Microwave Pioneer Award of International Symposium of Microwaves, Bengaluru, India. He was in the team responsible for the development of the first ever traveling wave tube in the country. He originated the DST multi-institutional project, in which the first ever gyroton in the country for fusion plasma heating was developed. He was a member of the DST steering group for monitoring the project. He was distinguished visiting scientist of CSIR and CEERI Pilani and consultant to DRDO MTRDC Bangalore. He, at present, co-chairs with ISRO Director a committee that monitors a project at CEERI Pilani for the indigenous development of a class of space-qualified TWTS for ISRO SSC Ahmedabad. He played a pivotal role in establishing MOUs between Department of Electronics Engineering, IIT BHU, and CSIR CEERI Pilani, between Seoul National University and CSIR CEERI Pilani, and between SKFGI Mankundu and CSIR CEERI Pilani. Not only that, he is a golden reviewer of IEEE transactions on electron devices. He is on the editorial board of the Journal of Electromagnetic Waves and Applications, and he guest edited special issue on microwave tubes and applications. He served on the Technical Committee on Vacuum Electronic Devices of the IEEE Electron Devices Society. Professor Basu took visiting assignments abroad at Lancaster University, UK, Seoul National University, Korea, Karlsruhe Institute of Technology, Germany, and University of Electronic Science and Technology of China. He was president of Vacuum Electronic Devices and Application Society, India. Welcome, sir. Please, sir will today enrich us with the scenario of microwave tubes research and development in India. Please, sir.
Guest of honor.
Thank you.
Excuse me, sir. Sir, 1 minute. Actually, we have made one mistake. Sir is also our guest of honor. Okay, so I request sir at first to give his lecture about the FDP. Then, sir, please continue with your technical session.
Okay. Just I will say.
Obviously, sir. First, you say something, your motivational speech. After that, you will take over for your presentation.
Okay, I think my presentation was scheduled at a later time, isn't it? Not now. My presentation of lecture, my lecture on this R&D, research and development scenario in the area of microwave tubes, is scheduled later, isn't it? Am I correct? Okay, this is the inaugural function, is it?
Yes, sir.
So let me say a few words, okay, in this function. Am I audible to you, all of you? Am I audible to you?
Yes, sir.
Yes, sir.
Okay, thank you. Of course, formally I say good morning to you, one and all present here. We have assembled here today to inaugurate the faculty development program on recent trends and advances in electronics, extending from 19th to 23rd September, 5 days, 5-day program at Dr. B.C. Roy Engineering College and Group of Institutions. I'm honored that I have been given the opportunity to address you on this occasion. The founders of this college are late Dulal Mitra, respected Dulal Mitra sir, Mr. Turun Bhattacharya, Mr. Jarnal Singh, Mr. Ratan Rai Chaudhary, and of course their associates. I salute these founders of the college for naming the college after Bharat Ratna Dr. B.C. Roy, in whose honor we celebrate the Doctor's Day every year on 1st of July. I am happy that the organizers of this program have received a great support from the trustees of the college, Dr. Satyajit Bose, Mr. Tarun Bhattacharya, Ms. Meeta Mitra, and their associates. Of course, hats off to the college principal, Dr. Sanjay S. Power, and his associates, which includes, of course, Professor Sarit Pal of Electronics and Communication Engineering Department of the college, for organizing this faculty development program. I have noted that Professor Pal, Sarit Pal, very judiciously selected the topics to be deliberated upon in the program. Professor K.P. Rai, he is here. Professor K.P. Rai is very much present here. He is going to deliver his talk on wideband antennas. Fortunate, he is internationally acclaimed for his work. He is now at Defense Institute of Advanced Technology, Pune, DRDO. Of course, I visited a number of times to that institute. Previously, he was at Sameer, Mumbai. S-A-M-E-E-R, Sameer, you must be knowing. I have seen him there develop a system for hospital remediation based on the microwave magnetron. Okay, he's very much recognized for, he was that time very much acclaimed for these particular contributions. The system is working now in many medical colleges, medical institutions, hospitals in the country. Professor Parthapratim Sarkar of Kalani University is going to speak on frequency selective and surfaces and their applications. That will interest you very much. Now, Professor Prashant Kumar Boshu was my classmate at the Institute of Radio Physics and Electronics, Calcutta University. He was my classmate. The attendees of the program will be fortunate to have a great scientist, Professor Prashant Kumar Boshu, among them, and listen to his scintillating lecture on electronics, photonics, plasmonics. Those who are interested in the application of sensor networks will be inspired to have Professor Shubrat Kaur among them to deliberate on this subject. Dr. S.U.M. Reddy, who was our PhD student at Banaras University and who was the director of DRDO Microtube and Research and Development Center, Bangalore, is going to acquaint the participants with the directed energy weapon of strategic importance. The system is used for information warfare. I'm happy to see that my friend, very close friend, Professor Hari Mohan Gupta, who was at IIT Delhi, is going to deliver a lecture on quality of services in WLANs. I would like to mention that Professor Gupta and I had a common guru at IIT Kharagpur in Professor Nirmal Baran Chakrabarti. I'm proud that we are students of the legendary Professor N.V. Chakrabarti. I would like to tell you that Professor N.V. Chakrabarti was a DSc in communication engineering from Calcutta University, but he was DSc in communication engineering, but he established a microelectronics center at IIT Kharagpur with the assistance of my another classmate, Professor Shomir Kumar Lairi. You can see how versatile he was. And he guided me, my PhD work in devices, vacuum electron devices. You'll be surprised how versatile he was. Professor S.K. Kak, who was my colleague and who was also the PhD mentor of Professor Sarit Pal at Banaras University, and who was Vice Chancellor of several universities in the country, he is a communication engineering expert, is going to speak on bio-nano interfaces to bioelectronic medicine. We are all eagerly awaiting the deliberation of Dr. Piali Boshak on applications of electronics in novel drug delivery system. Polarization conversion, and miniaturization of planar antennas will be discussed by Dr. Taposh Mondal. Dr. Pankaj Kumar Dalela was my student at Banaras University. We are at Institute of Technology, Banaras University, now known as IIT DHU. I am proud that Pankaj is now the director of CDOT. You know CDOT, standing for Center for Development of Telematics. CDOT, is the director of Center for Development of Telematics, CDOT. And he is very well known to Professor Harimohan Gupta. He will deliver his talk on telecommunication technologies in India for ICT revolution. ICT, standing for, if I'm correct, what is ICT? Inter Information and Communication Technology. Dr. Dipankar Pal will deliver two interesting lectures, one on classroom teaching and another on presentation of research. His lectures will surely arouse interest among both teachers and researchers. The well-known orator, Professor Rudra Ghatak of NIT Durgapur, has chosen his topic as circuit design challenges in new generation communication systems. I would like to draw the attention of the organizers that they may pursue Professor Ghatak to deliver a talk on engineering electromagnetics in future, at a future date. He is an expert in electromagnetic theory, and which is very much necessary for doing basic research and development in the area of electronics engineering and communication engineering. It is nice that Mr. Soumitra Kumar Bhome, who was a classmate of Professor Sarit Pal at Banaras University, will deliver a talk on adaptable and homogeneous systems on a chip. Very interesting talk. You must not miss it. Technical session will be taken up by Jyoti Electronics on CST Studio Suite. I expect that the participants must explore PIC simulation, particle in cell simulation in CST. There are simulation courses like Magic, etc. available for this purpose. Jyoti Electronics may look into it. They should include PIC simulation also in their program. Professor Sarit Pal has also given me a task to deliver my presentation on national scenario of research and development in microwave tubes in India. Well, friends, I must tell that there is a gap felt between what is taught in electronics and what is needed in industries as well as in space and defense sectors in our country. There is a gap between what is needed there and what is taught. There is a gap. Let us all strive for reducing this gap. Well, I do not like to stand anymore between you and the speakers to follow. Expert speakers will follow. And of course, I am also one of the speakers, but I'm not the expert. I'll just acquaint you with whatever is going on in the area of microactives in the country, in the scenario of R&D. I don't know when to speak on that. I thank you all for giving me the opportunity to say a few words. My greetings and best wishes to you. Namaskar, Jai Hind. Now I request the host to please take over the mic from me. Thank you very much. Namaskar.
Thank you, sir.
Namaskar. Namaskar to all of you. Namaskar. Now I think you have to plan whether to start the lecture session now or give a gap and start it. Just you decide.
I think we can start now.
We can start now. Already we have.
We can start.
Okay. Okay. Thank you very much. I will start.
Yes.
But let me try to tell you. Okay. Should I start? Thank you very much. I'm trying to share my share my presentation. Okay. Okay. It will take some time. Please bear with me. Am I audible to all of you? Am I audible?
Yes, sir. You are audible.
You are audible.
Yes, you are audible.
Okay. Please give me some time. Please don't mind and give me some time.
Okay, sir. No problem, sir.
No problem, sir.
Because I opened some other. That is on paper writing.
Okay, sir. Take your time.
So may I open the PPT?
No. Please do not. Let me try. Okay.
Okay, sir.
Please do not,
Okay, sir.
please do not open. I will open. It will take some time. Please don't mind. Okay.
No problem, sir. No problem.
Okay. Thank you very much. I am an old person. Is it? Is it? Can you see
Yes,
this?
sir. Visible, sir.
Very
Yes,
clearly?
sir.
Okay.
Yes, sir. Very clear.
Yes. My topic is this: scenario of microtube research and development in India. I am associated with a college in Mankundu, but I am not able to visit that for several years due to COVID situation. And normally I visit there for 4 to 5 days. I used to visit every month. Well, I am superannuated from Electronics Engineering Department of Banaras University. It is now known as IIT BHU, but it is previously it was known as Institute of Technology. Of course, I cannot present everything about. So I request you to read this one. All knowledge of God is confined to this or that book. How dare men call God infinite and yet to compress him within the covers of a little book? So I cannot cover in this lecture something about what is going on in the country. I thank Professor M.B. Karthikeyan of IIT Roorkee. No, now he's in IIT Tirupati. Now has changed his affiliation. And I thank Ms. Surya Rajita for formatting the PPT version. Okay. I may mention many points, the names of significant contributors to the microwave tube R&D efforts in the country. I may please be pardoned for such inadvertent lapses. Am I audible to you? Am I audible? Hello? Am I audible?
Yes, you are. You are audible.
Yes, sir, you are audible.
Thank you. Okay, these are the agenda. Quickly. Let me see how much I can cover. I will describe the efforts at Siripalani, MTRDC, Bangalore. The director of MTR, the Arts 12 director will speak here on something on information warfare. What is that called? What is that? DEW, Directed Energy Weapon. SUM Reddy will speak. Bharat Electronics, Bangalore, the manufacturer of microwave tubes. Something I will take about position paper. Consortium for execution of multi-institutional project. I'll come to that. Okay. Okay. Now the historical timeline. You know that it starts from flaming valve, etc., etc. I'll come to the 1920-40 Hull, the magnetrons, traveling up to HIF. I put the name in 1933. Okay, magnetron, Hale theory. Flystone, 1936 by this, and people know Varian Brothers, developed it. He also had a company, founded a company, Varian Brothers. Okay. Then, okay, now the modern gyrotron, this one. University of New Mexico, USA, DRD, NTRDC, India, CSR Siripalani, India, IIT BHU, some research. DAVB, Devi Ahalla Vishwavidyalaya, Indore. They did significant work in the area of relativistic backward wave oscillator. Okay. Now these questions, these objective questions, of course, the key is given. Transmission and reception of radio waves. See, success has many fathers, but failure is an orphan. Success has many fathers, but failure is an orphan. So transmission and reception of radio waves, who was the inventor? Somebody will say Marconi, Russian will say Popov, Indians say J.C. Bose, and somebody could say J.R. Pierce and so on. And the answer is, of course, C, Jessica. Similarly, traveling wave tube, who was the inventor? Komfner, Hayef, Lindenblad, or G.R. Pierce? I think when Professor Hariman Gupta was an MTech student at IIT Kharagpur, the traveling wave tube was known as Komfner tube. It used to be known as Komfner tube.
Yes.
Okay. Yes. But so actually, but Komfner is not the inventor. Answer is B. A.V. Hayek.
Yeah.
I'll tell you. So you see, 1942, this is a Komfner's notebook, 1942. 12th November, he written a completely untuned amplifier. Amplifier TWT, traveling active is an amplifier. Untuned, because it doesn't have any resonator. Okay, it uses a structure, helical wave structure. This is a helix input here, but he has not developed a complete. He's just imagining. Would it work? He's writing. Would it work? Would it work? Something he's writing. All right. So it is 1942 story in his diary, not developed. Next. 1940, he was not knowing, but in USA itself, he was an American, another American, Lindenblad, already filed a patent in 1940. This one. And helix sound around the outside glass envelope. Outside the glass envelope, it is found, okay? But the patent, many people do not know. I think Karsi is S.K. Datta, MTRDC. S.K. Datta was my PhD student at BHU, MTech and PhD student, and he's at MTRDC. Okay. The patent, DRDO, MTRDC, Bangalore, Microtube Research and Development Center, Bangalore, in 1933, but it is ignored. The patent, many people do not know this one. But one interesting thing I'll tell you, how great men think alike. You see, here this is a sketch of helix. Those helix is a wave structure which supports electromagnetic waves of velocity less than velocity of light, speed of light c. Now here, this helix is, I think it appears that he's not a good artist. It is clumsy like this at the end. Oh, no, it is not clumsy. He deliberately reduced the pitch of the helix towards the output end. This is output, it is written output, this is input. See, the electron beam delivers its energy and slows down. And in order to resynchronize the electron beam, the RF phase velocity of the electromagnetic wave has to be reduced. So that is why the pitch was reduced to slow down the RF phase velocity to resynchronize the RF phase velocity with the electron beam velocity. So this was the reason. It is not that he was a bad artist like many of us. And same thing, great men think alike. In this patent, 1940 earlier, deliberately the pitch was reduced. I tell you, it is because of that. It is not written anywhere, but I know it is because of that. I can understand it. And I have written here, pitch tapered for velocity resynchronization. Okay? Yes, I mentioned that he is the inventor. Hayef. You see, Hayef, there is a tube known as Hayef tube, which is based on, which does not use any wave structure. It uses two electron beams intermixed with one another and just I am remembering, I worked on Hayef tube at IIT Kharagpur. Okay. Somebody is bored. Somebody, I can see something in the background. Okay, I can hear something. So Hayef, there is a tube called Hayef tube, and that is called double stream amplifier. Interaction between two electron beams with close velocities. And I studied in my doctoral work the nonlinear effects in so-called hive tube, double stream amplifier, and beam plasma amplifier. Yes, also. And superiority of microtubes over solid-state counterparts, many of you know, but some of the points are written here. Lesser heat generated due to collisions in the bulk of the service. So I request you to please go through this for some time. Okay. Then I go to the next slide. I am not reading it. I'm not reading it. Please go through it. Particularly, tubes are inherently hardened against radiation and fairly resistant to temperature and mechanical extremes, being fabricated out of metals and ceramics. And okay. Now, in one of my books, see, some of it is a book by Vishal Kestri of DRDO and myself, my student Vishal Kestri. E.D.L. Shamilaglu of University of New Mexico wrote this thing about vacuum electron devices. Microtube is essentially a vacuum electron device. So please read. Read this one. I am just pausing for some time. Please read it. So E.D.L. Shamilaglu is a great scientist, expert in high power microwaves. E.D.L. Shamilaglu, American. Is it readable? Can you read what is written? Okay. Can you read what is written? Or is it readable? Can you read?
It is readable, sir.
Yes, thank you. Here, incidentally, in the foreword of our book, he wrote this. Interesting foreword. He wrote this. And you can get this book, of course, maybe, I don't know, maybe costly, I don't know. But you can, it is in 2 volumes, but short books, IOP book. It is instead of physics book. Incidentally, I am a series editor of myself, IOP publishers, Great Britain. Okay. Okay. Okay, let me pass on to the next slide. Now, the attempts were made to replace space derivatives by solid-state devices, but it is now not successful in view of the required MTBF, mean time before failure, in satellite qualified services. Thus, although SSDs were tried out in satellite communication system during the last decade of the 20th century, for instance, replacing 50% of TWTs with SSDs in 1995. Such replacements declined beyond 1998 to only 10%, making space TWTs more relevant than their SSD counterparts. So we are also in our country developing space TWTs. Now this is very interesting slide. Vacuum devices dominate here. High average power, and these are the region of competition. Solid-state devices is very much dominant. Lower powers, lower frequencies. At higher frequencies, of course, nobody can match vacuum electron devices. Higher frequencies and higher frequencies. Nobody can match vacuum electron devices and microtubes. This is a very interesting slide shared by the great scientist A.S. Gilmore, my friend, who has authored many, several books on microtubes. And he wrote an article on my request in a journal which I guest edited. Why use 1,000 mice when 1 horse can do the job? This is high power microtube is doing the job, and the solid-state devices, so many mice is there. They are put in parallel, they are put together to give the power. It is array of solid-state devices So if one microtube can serve the purpose, and why so many mice? So it is Karsi Gilmore, yes, Gilmore. Okay, he is suffering from, nowadays he's suffering from Parkinson and urotomy. And okay, so this is the power capability, output versus frequency ranges of typical microtubes. Okay, R&D efforts. I'm going to describe Indian efforts. Institute of Radio Physics and Electronics, Calcutta University, first to begin the efforts. Then, very important, first Calcutta University started making electron tubes, including magnetron. Some R&D efforts. Okay, because of the UNESCO expert H.F. Stesker at the institute. Then it started CSR National Laboratory, Padma Shri Amarjit Singh, NC Vaidya, first at NPL, then at Sri Pilani. And then CRMT did some basic research, NC Vaidya, and I was in that team. Microtube MTRDC Bangalore, Mr. Rajnaran, in 1984. I took a key role in establishing that center in the country. I held the DRDO scientists of DLRN to write the proposal, and eventually that institute was formed. Then, of course, some efforts are being made at IIT Tirupati now. Previously, IIT Roorkee, Devi Ayala Vishwavidyalaya DAVV Indore. Professor K.P. Maheshwari is working here. Karthikeyan used to work. And then Institute for Plasma Research, PK Satyanarayan Kulkarni. Of course, Mr. Raj Singh, I have seen he was there for some time. He's a very busy person at IPR, Institute for Plasma Research. I don't know whether he is present. He came for some time. Bhava Atomic Research Center, Mumbai, Ron, K.C. Mittal, Sanjay Malhotra, etc. Recently, Dr. Sanjay Malhotra.
I am present.
Yeah, Raj is present. Thank you very much. You are there. Okay. So Society for Raj is present here. He is the senior most scientist. What is that? G and then H outstanding or something. Huh? He's the very big scientist. He is here. Raj is here. Okay. And Society for Applied Microwave. See, Samir full form. Society for Applied Microwave Electronics and Engineering Research, Mumbai. It was enraged by. Now it is a center at IIT BHU. Sorry, what is that called? Guwahati. And the great expert from SAMI is present in this meeting. He is Professor K.P. Ray. He developed many, he is developing many centers. During the COVID day, he will arrange a separate lecture of Professor K.P. Ray on the systems he has developed during the COVID days for the COVID persons and so on. Please get him. He's here. And Shubrata Das developed the Gyraton window for a multi-institutional project. Okay, right. IIT Roorkee now it is IIT Tirupati. Karthik is there, MV Karthikeyan, and our student at IIT BHU, he was our student. Devi Ayala Vishwavidyalaya, great scientist, Professor K.P. Maheshwari, and Professor Choerle is now president of Vacuum Electron Devices Society India. Institute of course, the great scientist Dr. P.K. Kaur, and Dhiraj was there, Dhiraj Bora, Satyanarayana, Kulkarni, of course, Raj Singh, B.K. Shukla, Lakshmikant Rao, I think he was the coordinator of ITER India, and then Bhava Atomic Research Center, Mittal, Ron, Professor Ron, and then Malhotra, and now recent days, and then yes, Bharat Electronics Bangalore started producing magnetrons in 1969. And then it had a major collaboration in 1985 with Varian USA for TWT production. It also has collaboration with the EEV, English Electric Bulb Company, Thales, Philips, NTRDC, and CV. Well, Varian did not give collaboration, and a group from 40 persons went to Varian from Bharat Electronics, but they did not give the technical know-how for TWT helical storage structure. So there, I used to visit Bharat Electronics to tell them something about what Varian did not give at that time. Central Electronics Limited, Saibabad, established and produced magnetos. Now it is discontinued. Pilani Electron Tubes Private Limited, Sangrur. It is named as Pilani Electron Tubes. It is not in Pilani, it is in Sangrur, Punjab. Established by Dr. G.S. Sidhu. He was formerly at CV Pilani, and he was a student, MTech student, BTech and MTech student of the Institute of Radio Physics and Electronics. Now his sons Daljit and Gur Iqbal has taken the manufacturing of transmitting tubes triads and recently CW magnetrons and for diamond cutting industry in Baroda. And Indian labs and universities, of course, Bharat Electronics Laboratories, CRI Pilani, MTRDC, SAMI, DRDO, Bhagat Medicine Center, okay, University of BHU, IIT Roorkee, IIT Tirupati, Bardhaman University. Bardhaman University doesn't do its research, but their students are doing a lot of MTech work, research at CRI Pilani and some NTRDC Bangalore also. Okay. Now I am giving a very historical report shared by my friend Prashanta Kumar Basu of Calcutta Institute of Radio. He is going to deliver a talk in this program I told you earlier, in the earlier session. So he has given the Calcutta University report, work on electron tubes. UNESCO expert, he started in September 1956. And the details to high vacuum pumping, etc. is given. And then something is reported given, and then particularly machining of magnetron parts, I can see. And finally, the properties of okay. And 1950 progress report, 1958, 59 electron tubes. Their work is on progress towards better design performance of 10 centimeter multi-cavity CW magnetron. Karsi Prashant Kumar Boshu, my classmate. NV Chakra, and then I can see some something I found out, 1966 papers by NV Nirmal Baran Chakraborty. Sometimes he used to write O for Chakraborty, sometimes A. Lower frequency pumping of electron beam parametric amplifier, etc. It's a great, it is a genius. This is the setup at the Institute of Radio Physics Electronics. Historical setup shared 1956. The similar setup was built at NPL later on, National Physical Laboratory, Delhi, later on, and then at Siripur level. According to Professor P.K. Basu of Institute of Radio Physics and Electronics, P.K. Professor is Prashant Kumar Boshu. Steskel and his co-workers developed tube C60 3 centimeter magnetron and other devices requiring vacuum equipments and precision glass blowing, sealing, etc. at the Institute of Radio Physics and Electronics. Unfortunately, he could not give me the details of the magnetron developed, the performance of the magnetron developed. And I'm not sure whether it has been finally developed or not. I'm sorry. I do not know. I do not have any record. So the global list of some of the companies here, and in India, Bharat Electronics, of course. US sponsors, Indian sponsors. Role of magnetic field in classification of microtubes from various angles. I'm skipping this one. Okay. This particular document may be of importance to you. You can take the document from Professor Sarit Pal later on. Okay, I would like to pass on to some other thing. I don't want to prolong my lecture for many. for more than an hour. Okay, sorry. Vis-a-vis applications, wideband helix TWT where it is applied, narrowband where it is applied, radar, satellite, etc. CC means couple cavity TWT, radar, klystron, radar, particle accelerator for klystron. Okay, TV transmitter, satellite communication, micro, magnetron, magnetron, etc. Crossfield amplifier. It was first time developed in India by Dr. G.S. Sidhu, who was at Sri Pilani, where recently I was at Sri Pilani. I had visited Sri Pilani for a couple of days. Milo, magnetically insulated line oscillator, HPM BHU did some work in theoretically in this area. And now MTRDC is doing relativistic tubes, BW, was developed by Professor K.P. Maheshwari and his student Professor Y. Choel, who is now president of Vacuum Electron Devices and Application Society. Parketer is virtual cathode oscillator, reflex drive. It is a high HPM, high power microwave device. DEW, I think SUM Reddy will talk about this. Gyrotron, okay, gyro TWT, gyro klystron. Okay, I have myself trend-wise grouped microwave tubes grouped for improved performance, conventional microwave tubes like TWTs, magnetrons, but improved performance. MPM and micro fabricated tubes. MPM is microwave power module where solid state devices and microwave tube devices coexist. Okay, by gain sharing. And then IREV, intensive relativistic electron beam driven high power microwave tubes, and fast wave tubes, gyro TWT, gyrotron is a fast wave tube, and plasma field tubes for enhancing the power capability, and recently metamaterial assisted tubes. Okay, so some of the tubes I mentioned, 5, group 6. Okay, I'm just leaving this. Future trend-wise groups of group microwave tubes, ISRO, space TWT, defense DRDO, TWT klystron. System is radar, electronic warfare. RR is Raja Ramanna Center of Advanced Technology. DAE, Samir, they are particle accelerators, fast systems. They use magnetron, klystron. IPR, Institute for Plasma Research. I think Raj is here, Mr. Raj Singh. Plasma heating, electron sectoron, resonance heating, gyrotron, long power plus. These are the tube type, klystron, gyrotron, of course, they use. IPR, BRC, HPM, virtual cathode oscillator. Efforts of CRMT, we have done this work, helical sphere structure, field and equivalent circuit analysis, etc., nonlinear hydrodynamic analysis of TWTs, synthesis of Pierce gun, electron guns. CRMT has did this center of research activities, still so many activities, and nowadays a lot of activities in gyrotrons, gyro TWTs, backward wave oscillators, gyro twistron, etc. And efforts of CIRI, there are so many laboratories in CIRI, of CSIR series here, and from 6 to 12 I was there. September I was there at CIRI for some purpose. Okay, this is the entry of CIRI, a very nostalgic, this one, very close to my heart, my second home. Although I was at BHU, but after retirement, I was given the farewell at Sri Pilani. It is a unique thing in the country, in a CSL lab. Okay, and thanks to Dr. Joshi, S.N. Srinivas Joshi was group leader of the TWT group, which has the credit of developing the first ever TWT in the country. And Moria, magnetron expert, Ranjan Barik, Dr. L.M. Joshi, Ayan Bandyopadhyay, he was formerly a student of Bardhaman University. Dr. A.K. Ashok Sinha, he says that I am his first PhD student. Anirban Bera, again, he was a Bardhaman University student. Keeping me informed of these specs of the microtubes in the agenda of CSR Sri Pilani, I owe to them for the slides to follow pertaining to CSR Pilani. Okay, this is the band of TWTs. Yes, TWTs developed by Sri Pilani. Okay, of course, the information has to be updated for many applications like ISOSAC, DRDO, etc. Okay, these are again development of magnetrons. Courtesy, of course, S.N. Joshi. He has given me this slide. Technology development RF windows for this one, and S-band magnetrons, S-band CW2 magnetrons, etc. Various types of giving developed by magnetrons, clystons. These are the things. I have seen all those things myself. It's worth visiting. You can go to Sri Pilani. This is the efforts of Sri Pilani. Clystone developed at Sri Pilani. Okay. Efforts of Sri Pilani is continued. Okay. Information to be updated. I'm writing to be on safe side. Efforts of Sri Pilani. You can see the vast work has been done in this area. And then Sri Pilani plasma-based devices. And of course, Raj is here. He will certify. Plasma cathode electron gun, plasma-assisted microwave sources, Pasotron. Okay, actually I motivated them to develop this device, and they have developed it. And excimer sources, UEV, etc. Ozone generation applications, hyper plasma device switches, etc. Low atmospheric pressure plasma devices, portable and tunable extreme ultraviolet devices. MTRDC, Bangalore. It was established in 1984, and I helped them preparing the proposal for establishing this to some of the DRDO scientists, including Mr. A.N. Murthy of DLRL. Okay, Mr. Rajnarayan, of course, effectively the first director, then followed by K.U. Limai, originally from LRD, Bangalore, then Dr. Lalit Kumar, who was previously at Sri Pilani, and then Sudhir Kamath, our BHU student, who became, he was the director at MTRDC, and then he became Director General of Cluster of DRDO, my MTech and my PhD student, Sudhir Kamath. SVM Reddy and our student, G. Bishop now, has taken over. Nowadays, MTRDC has become part of LRD. It is a department of LRD now, due to some administrative reasons. Okay, so these are the class of microtubes. Helix TWT is developed by MTRDC. Most of I monitored the development of most of these tubes at MTRDC. And then efforts of DRDO, some published paper by Lalit Kumar. It is there. They have documented this here. I think it is some publication. Another review. Okay, efforts of DRDO, MTRDC, power booster, Helix TWTs, and microwave power modules. In microwave power module, solid state SSP, solid state power amplifier, and TWT coexist by gain sharing. There is a electronic power conditioner. It is just like a laptop, size of a laptop. It is a complete system. Thanks to Raja Ramana Rao of DRDO MTRDC for drawing my attention to DRDO Technology Focus June 2015. Useful document which was brought out by the initiative of Lalit Kumar, erstwhile director. This is the document of my prepared by Lalit Kumar and documented. Okay, Technology Focus June 2005. Okay, so I think my lecture takes a lot of time, so I am just cutting down. But to give you an idea about what is there in microtubes in the country, the policy of Bharat Electron is good services is when customers come back and the goods do not come back. Okay, so it was 1954. I used to visit Bell at least two times a year. Now, of course, I cannot do that. Bell tubes, These are the bell tubes developed, commercially developed, and know-how they are taken from many institutions in the country, and of course the MTRDC and USA variant, Thomson CSF, now Thales, Estoc, Russia, etc. Bell TWTs are these are the Bell TWTs developed. Bell numbered is there. The parts of Bell. Bell clystrons, Bell magnetrons. Now, very interesting document, requirement of microtubes in the coming 10 years. This is an old document, but it was prepared in April 10, 2006 by my friend, Dr. Chandrasekhar. He was the director of Sri Pilani, and he is now the Chancellor of Academy, CSR Academy of Scientific and Innovative Research. He prepared this document. He is an expert in VLSI, and he, along with Dr. S.N. Joshi of Sri Pilani, prepared this document. I can see in 2006, and you can see requirements of microtubes has been estimated by Sri Pilani based on the deliberations at the technical meet of all concerned R&D, academia, production, and user organizations held on April 10, 2006 at CSIR Vigyan Kendra, New Delhi, to generate position paper on the requirement of microtubes and their development for the coming 10 years. That means what I am going to present is valid up to 2016 only. So such position paper needs to be prepared from time to time, and it has to be delivered. Somebody has to take this charge, responsibility. Okay. Now the requirements at that time for next 10 years, ISRO, TWT, so many tubes. Within parenthesis 60 within bracket means 60 tubes are required. 15 tubes are required for 40 watt X band 40 watt tube. 15 are required, for instance. This is required by ISRO. Similarly, RCI, it is in Hyderabad, Research Center of Emeritus. It's a DRDO. It is a brainchild of our Kalam sir, Professor Kalam, very close to me, Professor APJ Kalam. Pulse miniature TWTs, K band, etc. CWT miniature tubes are RC required. Okay, LRD, Electronics and Data Development Establishment in Bangalore, they also TWT gave the requirement. DLRL is Defense Electronics Research Laboratory. L stands for electronics because see, L stands for electronics in DRDO scenario. Okay, not anything else. And laboratory, L laboratory. MTRDC. Reasons I can tell you, but you can research by L stands for electronics there. Like LRDE, Electronics and Data Development Establishment. S stands for electronics. Electronics and Data Development Establishment. You please do, I know the answer, but you please investigate into that. Okay. DEAL, it is in, what is that? DEAL, ADA, RRCAT, this is Indore, Center for Advanced Technology after Rajaramana. Okay. Right. These are the requirements, pulse clystron 14s, RRCAT, BRC, clystron. IPR also that time gave requirement. 500 kilowatt, 22 IPR for Gyratron, they have given a lot of requirements that time. Okay, IPR gave this requirement. CW gyratrons, 140 gigahertz, 500 kilowatt. Of course, they are taking gyratrons from JICOM, Russia nowadays, but maybe eventually they will take our country-made gyratrons. Let us hope. Samir also gave, Bharat Electronics is manufacturer of tube, but they also test their requirement. Samir and gyratron. Bell for ITER gyratrons, 50 numbers they wanted. ITER stands for International Thermonuclear Experimental Reactor. Okay. Other than microtubes, of course, tetros, etc., Siri Pilani and Pilani electron tubes make it. Thyratron, Siri Pilani. Okay. Now, there is a consortium for the execution of multi-institutional project, which it was originated by me at Banaras University, passed on to the document to Professor R.K. Jha, who took it to DST, Department of Science and Technology, and a project was executed 42 gigahertz, 200 kilowatt CW or long pulse Geraton using a 1.6 Tesla suitable for 42 gigahertz, 6570 kV, 10-15 ampere. T0 excited T03 mode. This mode we selected by consulting with my friend at Karlsruhe Institute of Technology, Manfred Thum, and of course Karthikeyan was there. Siri Pilani was supposed to develop electron ion, beam tunnel, collector, fabrication of all parts, assembly, integration of parts, and Siri Pilani was the nodal center. S.N. Joshi was the national coordinator for that entire project. Samin was developed by has developed window of the Geraton. It was developed by Shubhrata Das of Samin. IPR Gandhinagar magnetic focusing structure, thermal management, power supply, and plumbing line. BHU cavity and nonlinear taper. My student, Professor P.K. Jain, now he's director of NIT Patna, was responsible for this work. IPR Gandhinagar, so many persons are there. And IIT Roorkee, of course, Karthikeyan, analysis and simulation, and any theory, any workout he used to validate by his code. And Bharat Electronics is one of the members of the steering group. I was a member of the steering group, but Bharat Electronics is one of the members of the steering group of the project, with the understanding that the production of the Geraton would be eventually taken up once designed and developed by Bharat Electronics. And this is design center, Siri Pilani, Samir Mumbai, CRMT, BHU, IIT Roorkee. Testing center is IPR Gandhinagar, Siri, Samir. It has been tested with the support from Samir Mumbai expert. The magnetic field he provided, and then it needs to be further tested, and the help of IPR Gandhinagar is very much awaited for this, for further testing. It is still alive, the TV is still alive. It is a development center. Okay, this is the academic institutions who are doing work in the area. Bardhaman University I'm writing, but they do not do research over there. The students have done MTech, they do MTech research elsewhere in the country, particularly IIT, Siri Pilani, IIT BHU, IIT Roorkee, and then I think by mistake again Roorkee, it should be Tirupati, Manasthali Vidyapith, Rajasthan, somewhere, Supreme Knowledge. Supreme Knowledge Foundation group of institutions do not do work. Maybe I'm doing an old person doing some work. But their two students have done very successful as well in Siri Pilani. One of the student is Shubhradeep Chakrabarti. Another student, now Subhradeep is a scientist over there. And another student is a versatile person. He is Ratin Guho. He is one of the metamaterial experts in the country. He is expert in metamaterial assisted microtubes in the country. Another expert is going to give a lecture. No, he is not going to give a lecture. He's Suval Kaul, but he is not going to give a lecture in this program. And then Devi Al Vishwavidyalaya. These are the academic institutions still working in the area of microtubes. Students who obtain their postgraduate degrees in related tubes. List of students is rather long. I have mentioned Dr. Go. They are the dean. He attended my MTech class. He did not attend my MTech class, of course, then, because I visit there. Now here I have a very interesting table. Here the list of students of Bardhaman University who have completed their thesis work at CDP, and they are now very, very renowned persons like Minal Goswami, I think is the DRDO, Chandirpur, you know, I think is there. Shubhendra Maurya, Siripilani, Geraton expert, Anan Bandapadhyay, Plaston expert, Siripilani, Hasibur Rahman is an expert, plasma devices. Anivan Bera is at Siripilani. Hasibur Rahman is in a private college nowadays. Rodro Ghatak, the great scientist, NIT Patna. Okay. And then Sharmani Basu and so on. And then other names you may see, you may understand, you may know. Okay, I can see Jyotirmay Khona and so many people are there. Devashish Mondor, now a student of Karthikeyan. Now he's at IIT, NIT, what is that called? IIT Roorkee. And he created my website. I have a website created by Devashish Mondor. And now being looked after, of course, by Dr. Guru, not Devashish Mandal, but he created Devashish Mandal. He's at IIT Roorkee, but he's registered at IIT Roorkee, but his guide is MV Karthikeyan. And you may know many of these persons. I may not know them. Okay. Veda Society, there's a society formed, Vacuum Electron Devices and Applications Society. Veda, the name was coined by me long ago. Veda, I coined this name when it was established. So, organized every year, either a workshop or a symposium. So you can see series. And 1919 it was at Patna. Then at Guwahati in 18, I attended both this. And one thing, now they are going to attend, I think MTRDC Bangalore is going to organize in January next year, this society program, workshop, symposium. Okay. Okay. Concluding remarks, a glimpse of the progress of R&D in microchips in India vis-a-vis global trends has projected the strength of India in the area. It is hoped that this document will strengthen the collaboration between the microchip researchers and developers in India and abroad. The area being of strategic importance, the self-reliance in the area is very much called for. The area is a closely guarded secret area, so one has to develop the tube themselves. I would like to share my at the end. I think how I come up to thank you. Okay, bibliography. So there, I think I am highlighting myself. B.N. Vasu, my first book, Electromagnetic Theory and Applications in Beam Wave Electronics. And then again, many important other books are there. And then Vishal Kesriyar Basu, it is in 2 volumes, IOP publications. I'm the editor of the series of nowadays, series of electromagnetics and metamaterials of IOP. And same person, same volume 2. So then Gilmore, B.N. Vasu, Indian efforts in vacuum electronic devices organizations and persons in my perspective. What is that? It is a paper, Veda Society. Another interesting article I wrote. What is that called? B.N. Vasu, some paper. No. I think there is a article I wrote, Dr. Amarjit Singh on Dr. Amarjit Singh. I think his article with the multiple authored by American and Chinese persons. American, I can see Shapiro, MIT, and Chinese people. And now I can see Amit Kumar Bashnev. Now he has led that one, that college, Mankundi College. What is that? Okay. Okay, I have come up to thank you. Thank you very much. But I want to tell you that I had a very interesting experience to share with you. I was in China. What is that called? there is a University of Electronic Science and Technology of China at Chengdu. Okay, so I was there for the entire summer vacation, and I noticed, and I also published some papers recently with them in 2021 and probably 2022. Paper accepted or published 18, and every year I'm publishing papers with them in IEEE transactions or elsewhere, mostly IEEE transactions on electronic devices. And I had the experience that in the university they designed the tube, but all the design is sponsored by companies in China, and they develop the tubes. So all the work done in the university goes into the production. I must say they are very much self-reliant. They do not depend on Americans. Okay, if they need the cathodes for a microtube, they make the cathodes. They do not buy cathodes from do not depend on spectrum of cathodes of USA. If USA doesn't send us cathodes, we stop. So we have to develop cathodes, and the capability is there. Okay, Siri Pilani, SVM, what is that? Dr. R.S. Raju has developed. Yes, but there is some policy should be there to take it. And then the team of Dr. K.S. Bhatt of MPRDC has developed. The country should have the courage to use them in their microtubes. Then only self-reliance will come. With this, okay, I stop sharing. Thank you very much. Can you hear me? Hello? Hello? Can you hear me?
Yes, sir. We can. Yes, sir. We can hear you.
Oh, I'm stop sharing. Okay. I'm stop sharing.
Okay.
Okay.
Thank you, sir.
Okay,
Thank you very much.
Okay. I'm stop sharing, but I'll back to the. Okay.
Hello.
Yes, I'm stop sharing and coming back to.
Hello.
Yes. Have I come? Oh, Professor Raghavan is there.
Thanks to Dr. Sarita Paul.
I would like to.
The participants are lucky to have had the giant of microtubes of India. This 40 minutes is introduction time only for Dr. Basu. I wish the same college arranges one full week of FDP of Dr. Basu. Dr. P.K. Jain himself, in the presence of Dr. Raj Singh, has recognized Dr. Basu as J.C. Bose of India. But with respect to today's talk, I would like to tell some participants, at least those who are not aware, the person who gave a talk, definitely I can say is a living Spangenberg, living Gilmer, whatnot. So he has simply told the topics only. So each one is a ocean. He has put all those things in an atom and given to you. He's not a theoretical person. He has played with all tubes, TWT, magnetron, everything. So I can say he's a Watson, he's a Spangenberg, many more. Anyway, once again, I thank Dr. Sarita Paul for having given me the chance to hear the lecture. I only wish he gets Batma Awards and Nobel Awards. None of the words are exaggeration, little only of all the things. I hope Dr. Raj Singh will endorse my words. It's not easy to get endorsement from Dr. Raj Singh, but whatever I say, likewise, researchers should know how to write theses, many things. Thanks a lot.
Thank you, sir. Thank you very much. All the participants will be enriched with your valuable and informative thoughts and talks. So anyone, any question, please?
I don't have a question. I have a little comment. It was so nice to listen to Professor Basu after so much time. Okay. And one important aspect which he emphasized is that we have to have the capability built up in this country, and we have to keep on running on this. We just can't stop at any point because technology is changing so fast. And in fact, the three big organizations who have responsibility to do this kind of a thing, these are CSIR, DRDO, and Department of Atomic Energy, and also ISRO. And all these things need to combine with the academic institutions to establish the strong groups. And they should be very interactive to create these capabilities. I have been involved in several DRDO projects. And until or unless we look at those projects and requirements, we in academics will never know how to work. So this interaction is extremely important. That's what my comment was.
Thank you, sir.
Actually, subsequent to this, sir, I would like to also add that with the Professor Basu's talk, we have seen that there are so many requirements. Earlier, we used to say that industry cannot flourish in India because requirements are not there. But seeing on this talk of Professor Basu, sir, I found that requirement is too much basically. Now, the problem that I anticipate is that it comes because of due to cross departments. There are different departments under different ministries which are handling all these things, and there is a lack of coordination among them. So we have to find out some ways that all these efforts are, all these coordinated efforts are made so that the things can progress basically. That's what I feel actually.
Thank you, sir. Anyone, any question? Okay, so again, thanking you all, Professor Dr. Baidyanath Basu sir and all the dignitaries and all the respected faculty members present here. I like to end the first half of today's session, first session. Our second session in second half will start from 2:30 p.m. after lunch.
Thank you very much.
Thank you all.
Thank you all.
Thank you so much, sir.
Very nice talking to you, sir.
Thank you very much, sir.
Thank you.
We were waiting this type of talk.
I would like to leave, okay, for some time. Okay.